Hello guys, welcome to Ramta Solutions. Today in our lesson on differential or differentiation calculus, we are sketching cubics. Okay, so at the end of this lesson, you must know how to sketch these graphs. Okay, so a tip is that when A is positive, but you will understand this, when A is positive, your graph looks like this. When it is negative, your graph looks like this. However, let's not waste any time and get into what we are doing today. So we will begin by introducing cubic graphs, right? Because by now you have done hyperbola, parabola, exponential, straight lines, and trigonometric, but you haven't done cubic graphs. So you will understand what they are and what is their standard form. And then we will look at steps that are used to sketch cubic graphs. And finally, an example where we will be sketching them. Okay? An example where we will be sketching them. So without any waste of time, let's get into the work. So in our introduction, let's begin by saying to you, cubic graphs have the form, let me say f of x. I don't want to use y. So we'll say f of x equals ax cubed plus bx squared plus cx plus d. Okay, so when this a is positive, your graph looks like this. So we should say a tip here is to say it ends with a smiling face. Okay, it ends with a smiling face. Okay, it ends with a smiling face. Now, when A is negative, our graph looks like this. So for this one, it means it ends with a frowning face. Okay, it ends with a frowning face. Okay, so these are the things that you need to look at whenever you sketch your graphs. Look at the value of A. If it's positive, you must know it ends with a smiling face. If A is negative, it ends with a frowning face. So obviously, by saying it ends, I mean if it ends with a smiling face, you must know it begins with a, if it ends with a smiling face, it begins with a frowning face. If it ends with a frowning face, it means it began with a smiling face. Okay, so I will not look at other parameters. I will only look at D. This D is the y-intercept. Okay, it is the y-intercept of your cubic graph. Okay, it is the y-intercept of your cubic graph. Okay, so these are the things that I will be looking at right now. Okay, in this video, we're going to look at the cubic graph and we are going to really enjoy this. Okay, we are going to really enjoy this. Now, let's then look at steps steps to sketch the graph. Okay, what graph? The cubic graph, right? Now, steps to sketch the cubic graph are, number one, you don't necessarily need to note the value of A, but maybe pay attention to it. Note the value of A. Okay, note the value of A. So if this A is positive, we said it ends with a smiling face. And then if this A is negative, it ends with a frowning face. All right. Number two, find y-intercept. Right? Find y-intercept. So to find y-intercept is basically to say, what is the value of D? Right? What is the value of D? So basically we're saying y-intercept equals D. Right? Y-intercept equals D. Can you see that? Perfect. The third step, when you want to sketch these, is to now find x-intercept, right? Is to find x-intercept. So this, the previous video, I showed you methods of solving for x, right, for cubic expressions, right? So by now you know how to solve for x on a cubic expression or equation, right? Number four, find stationary point. Okay, find stationary point. Remember, these stationary points, you basically know them as turning point. Okay, you basically know them as turning point. Remember, you had a turning point in your quadratic graph, I mean your parabola. So these are still the same thing, they mean the same thing. These are stationary points, all right? So because it's a cubic, as you can see, it looks like it has two turning points or two stationary points. Can you see a point here and a point here? Okay, so you find your stationary point. So how do you find your stationary points? First thing first, find f prime x, meaning differentiate your given cubic expression, differentiate it, and then equate it to 0. Okay, solve for x. Okay, after solving for x, you will get your stationary point. And I solve for x for this f prime x, the first derivative. All right, then solve for x. All right, I repeat, find the first derivative, equate the first derivative to 0, solve for x. Okay, let me wait for you. Solve for x. Now, after solving for x, I will show you, just waiting for you guys to finish. Okay, it's fine. You can slow down the video. Solve for x. Then, after solving for x, substitute the let me say derived. Okay, substitute the obtained x values into f of x. Pay attention, I am not saying f prime x, I'm saying f of x. Substitute the obtained x values into f of x. Okay, this will give you the corresponding y value for those x values. Okay, they will give you the corresponding x values for, corresponding y values for the x values you obtained when you are solving for x here. Okay, perfect. By the way, here I must say, it means you are saying, here I must say, when I say find x-intercept, it means you must say f of x equals 0, right? Perfect. Obviously, when you solve for x, y must be 0. Okay, so you substitute the obtained x values into your original formula. Okay, into your original formula. Remember, not into first derivative, into your original formula. Then you will get the corresponding y value, and this will give you the point with its x and y value, 2 points to be precise. Okay, now the fifth point will be find the point of inflection. Find the point of inflection. Okay, this point of inflection is basically the point where the function changes its concavity. Okay, this is point where function changes its concavity. We'll talk about concavity later. Okay, this is where a function changes its concavity. So to find the point of inflection, a tip is this. First thing first, find the second derivative. Okay, find the second derivative of your f of x, meaning of your original expression. Or your second derivative is the first derivative or is the derivative of the first derivative. Okay? So then equate your second derivative to 0. Second step under this, solve for x. Then again, substitute the obtained x value, right? Substitute the obtained x value into f of x to get the corresponding y value. Okay? To get the corresponding y value. Alright? To get the corresponding y value. Then, finally, you can sketch the graph or draw the graph. Okay? Finally, you can sketch the graph or draw the graph. Okay? So these are the steps that you need for you to sketch your cubic graphs. Okay? These are the steps that you need for you to sketch the cubic graphs. Right. So we are not going to waste any time. So I'm going straight into an example. Okay? I'm going straight into an example. Maybe this was number 1, it was introduction. Number 2, it was steps to sketch the graph. Number 3 will be example. Okay? It'll be example of sketching the graph. So our example is this. I'm just going to do an example. Sketch the graph of f of x equals x cubed minus 6x squared plus 9x. Okay? Sketch the graph of f of x equals x cubed minus 6x squared plus 9x. So, as you can see, we're saying we have f of x equals x cubed minus 6x squared plus 9x. Alright? We know, when you look at this, if you recall, we said a cubic has the form f of x equals ax cubed plus bx squared plus cx plus d. Now, when you look at this, it tells you a is positive. So we expect our graph to end with a smiling face. So if it ends with a smiling face, it means it began with a frowning face. So we expect our graph to be like this. Right? Now, let's find our y-intercept. Our y-intercept, we say basically y equals d. So what is it? Do we have a constant here? We don't have a constant. Alright, so this is equal to 0. So the coordinates of the y-intercept are 0 and 0. So this means it passes through the origin. Okay? This means it passes through the origin. Okay? So we are done with y-intercept. Let us now go to the x-intercept. Now, for the x-intercept, we will say f of x equals 0, right? We mean, in other words, y equals 0. So, what is f of x? It is x cubed minus 6x squared, minus 6x squared plus 9x equals 0. So this is easy to solve or to factorize because I see there's a common factor x. Let me take it out. X into x squared minus 6x plus 9 equals 0. Alright? So we have, again, we need to further factorize this. X into x minus 3 and again x minus 3. So it's repeating. Right? So what are our x values? They are x equals 0 or x equals 3. Okay, because you can see it is repeating. x equals 0 or x equals 3. All right, perfect. We are done with the x-intercept. Now let us look at stationary points. Okay, let's see. Okay, we saw the shape that it must end with a smiling face. Y-intercept, we obtained it. X-intercept, okay, the coordinates of the x-intercepts are 0 and 0, which is the origin, and 3 and 0, right? And by the way, when you see that some of the roots are repeating, this means there will also be a turning point, but we will see. Okay, so we are okay now, and let's then head to finding stationary points. Let me just call them SPs, okay? But please write stationary points. So to find your stationary point, remember you had said f of x equals x cubed minus 6x squared plus 9x. We need to find f prime x. What is it? It is 3x squared minus 12x plus 9. Remember what we had said. We equate f of x to 0. So 0 equals 3x squared minus 12x plus 9. As I can see here, we have 3 that is common to all terms in this equation. So everything divided by 3 is x squared minus 4x plus 3. So further, we can now factorize x minus 3 and x minus 1, right? Therefore, this means x equals 3 or x equals 1. Now remember what I had said. I had said after you have obtained your x values, substitute them into your original equation. What I mean is now say f of 3, what is it? F of 3 means on f of x, where there's x you put a 3. So it'll be 3 cubed minus 6 into 3 squared plus 9 into 3. You have a calculator, you can press this on your calculator, you will be sorted. So I don't have it now. 27 minus, what is this? 9 times 6, 16, 36 plus 18, 36 plus 18, 46, 46, 54. Could it be 54? I don't know. Minus, what is this one here? 9 times 3 is 27. Sorry, it's a positive 27. So this is 0. Right? This is 0. Now let's also look for f of 1. What is f of 1? F of 1 is, where there's x, I put 1. 1 cubed minus 6 into 1 squared plus 9 into 1. We have 1 minus 6 plus 9. This is 10 minus 6. It is 4. Right? It is 4. Therefore, okay. I hope I didn't lose anyone along the way. This, you don't have to be doing this part here. You can just plug this into your calculator and get your answer. Okay? All right. So as you can see, when x is 3, y is 0. So we have 3 and 0. And, sorry, SPs are 3. Oh, let me do this. So stationary points are 3 and 0 and 1 and 4. Right? 3 and 0 and 1 and 4. As you can see, I said stationary points are 3 and 0. And I remember saying to you, if your roots are repeating, that repeating root will also be a stationary point. And we just found that out now. Right? Okay. So now we found the coordinates of the turning point. Now what do we need to do? Now we need to find the point of inflection. So point of inflection, let me just call it PI. So point of inflection, we will say, remember, f of x equals x cubed minus 6x squared plus 9x. F prime x was 3x squared minus 12x plus 9. F double prime x will be 6x minus 12. Right? So we need to equate f double prime to 0. What is it? It is 0 equals 6x minus 12, which is 12 equals 6x. Therefore, x equals 2. Right? X equals 2. Having said that, you will now need to substitute this value into your f of x to get the corresponding y value. So this is f of 2 equals 2 cubed minus 6 into 2 squared plus 9 into 2. What is this? It's 8. 4 times 6, it's 24 plus 18. So let's see. We have, let me see. So we have, let me see what we have here. It looks like we have, what is this? 26 minus 24. Our answer is therefore 2. Therefore, our point of inflection is 2 and 2. I want to show you an alternative. To finding your point of inflection. Okay? I will show you an alternative. Method 2 would be midpoint of stationary point. Okay? Midpoint of stationary point. It is x1 plus x2, okay, x sub 1 plus x sub 2 all over 2, and y sub 1, I believe, y sub 1 plus y sub 2 all over 2, I believe. What will it be? It will be, let's see, it will be, let's say our points were 1 and 4. What was the other one? 3 and 0. So let's say this one is 0.1, this one is 0.2. So it will be, its x value, it will be 1 plus 3 all over 2. And it will be 4 plus 0 all over 2. What is this? This is 4 over 2 is 2. 4 over 2 is 2. So this is, therefore, point of inflection is 2 and 2. Can you see that? The coordinates of the point of inflection, okay? The coordinates of the point of inflection is 2 and 2. We also found it this way, okay? Remember, I'm saying the point of inflection is the midpoint of your stationary point. All right. So now let's sketch the graph. The maximum y value, let me confirm, the maximum y value was 4. The minimum was 0. Okay. Yes, the minimum was 0. The maximum x value, minimum x value or maximum x value is 3, minimum is 0. Right? Yes. Our minimum is 0. Okay. So what we can do, I will now plot. Let me plot. Okay. When we sketch it, we have, let me say 1, 2, 3, 4. Nngwe, pedi, tharo, nne. Okay, 0. All right. So let me change the color here. So we said our y-intercept, let's confirm it was 0 and 0. All right, our y-intercept was 0 and 0. Perfect. 0 and 0. Our x-intercept were 0 and 0 and 3 and 0. Perfect. our stationary point were 3 and 0. Our stationary points were 3 and 0 and 1 and 4. 3 and 0 and 1 and 4. 1 and 4. Here is it. Let me do this. This is y. This is x. And then our point of inflection was 2 and 2, somewhere here. So remember, point of inflection is where the graph changes concavity. And we said our A is positive, right? A is positive. So we expect the graph to end with a smiling face. So this means we go this way. Let me also note this point here. At this point, your graph must be like this, because I do see that this is the concavity, so it must be like this. Okay? So it must be like this. However, normally when you draw, especially on paper, you won't necessarily see this point here. Okay? So we said this one was 1 and 4. You won't really see this change, but this change is supposed to look like this. This one is 2 and 2, and this one is 3 and 0. Right? This one is 3 and 0. Obviously, this is 0 and 0. As you can see, our graph, indeed, it's ending with a smiling face because A is positive. And this is how you sketch your cubic graphs. These are the steps that you follow. Okay? These are the steps that you follow. And this is it, guys. So see you next time. And by the way, we will be looking at concavity. So bye-bye.